In this example, I'm going to explain how to do some KNN modeling and how to set the problem up and how to also do the partitioning and to test for overfitting in the KNN process. Here is a description of the data that we have. This is from the UC Irvine Data Repository. And really what this data set is about is there's a marketing campaign that's been conducted to get banking customers to accept term deposits. That is, they'll put their money in and leave it in for a certain amount. It's kind of like a CD, certificate of deposit. And we have some information about the customers, about their age, type of job they have, and their marital status, and the different things about, the balances in their accounts and whether they have a personal loan and so forth. We always want to look and see if there's collinearity problems in the data, and we have some categorical data and we also have some numeric data. Here's the data set. You can see that our outcome variable is binary, and we also have another binary that is in here in terms of the loan. So whether they have a personal loan or not is a yes or no. Now we'd like to be able to, for the binaries, we can approximate the numeric responses in terms of correlations by just converting or creating a copy of these fields that are zeros and ones, zeros for no's and ones for yeses. It's not perfect mathematically, but it's close enough for us to be able to do an evaluation. And remember, we're trying to get some sort of sense as to whether how much these input variables have a linear relationship to the outcome variable. And even though KNN is not based on linearity per se, it's still good to be able to see if there's linear information in terms of helping us make a prediction, and to be able to look for collinearity, because collinearity will really confuse KNN. So we certainly don't want variables in here that are collinear. So let's do a little bit of processing here to be able to do a correlation matrix on term deposits and also include a 0, 1 for loans. So I'm just going to make some new fields over here. I'll call this one deposits numeric, just number, and then I'll also make a loan number. And again, this is just me doing some quick checking and converting these over to zeros and ones. So I'll say if this equals yes, then we're going to have Excel insert a 1, and otherwise we'll have Excel insert a 0, and we need to have a quote there. All right, and then we're going to do the same thing for loan number. If that equals yes, then make it a 1, otherwise make it a 0. So this is just some quick processing, and then we can copy this down the sheet so that we've got, when it's a 1, for a yes, now it's a 1, and over here for loan, this was a no, and so we have a 0. So we'll just use this for our correlation matrix. All right, so now I'm going to import this and open this up. I can jump and do some work in jump now. So we'll save this and get into jump. You'll notice in jump that it looked at the content, and if they were numbers, it assumed that they were continuous numerics, and if they were categoricals, that it assumed that they were nominal categories, which is good assumptions. And then here are ones that we took from a category down to binary zeros and ones. We'll just use those temporarily to be able to produce our correlation matrix. So now we'll analyze multivariate modeling, multivariate, and we are going to take first our y variable, because it's always easiest and nicest to have that sort of on the left because it makes it easy to compare everything else to it. And then we'll take all of the other numeric variables, including this one that we made out of the loan category, and put those in. All right, so if we look down here, we're going to notice that in relation to the outcome variable, there is not anything that has a very strong linear relationship. There's really nothing here that is, jumping out, and we can also look down here in the scatter plots, and we can see that we don't have anything that's really strongly positive or negatively linear, and so that's helpful information. we can look over here and we don't see anything that has strong collinearity. Now that we've produced this correlation matrix, then we can go on from here. We did what we need to with these fields, and I don't want to have to remember them all the time, so I'm just going to delete those since they're just derivative of the other fields that we have. So I'll just delete those columns to make processing easier going forward. So now it's time to do some KNN on this, and what we want to do is we want to control for overfitting, and the way we're going to do that is we're going to have a three-way partition. So KNN uses the validation partition to be able to determine what is the best K. So let's do our partitioning going into predictive modeling and make a validation column. We're going to do 0.5, 0.3, and 0.2. And we'll say it's a 3-part validation, and it's in a ratio of 5, 3 to 2, and we'll select a random seed of 1. I'm just leaving little reminders in the column name for myself so I can remember how I did the partitioning. All right, so now let's do our KNN analysis. And as we go over here to our KNN algorithm, notice that what it does is it gives us a default K of 10 nearest neighbors, and it will go 10, 9, 8, and so forth down to 1. That's a bit low. My experience suggests that we should start that more around 15. We can do it here every time, but a more convenient way to do it would be to go over into the jump settings. So if you go to jump and then go to preferences, and in preferences go to platforms, go down to K nearest neighbors, select K, and then select that to 15. So that will set the default to 15, apply that. And that way, when we are working with our nearest neighbors, then it will be set up correctly. So now we have 15 here, and let's set up our model. Here are our results, and so the lowest error that it found was K equals 10, and you can see that that's about 10.9%. If you look over here from the validation to the test, you can see that these are actually lower in the test. So we really are not getting overfitting happening. When we use the validation partition to determine the best value of K that produces the lowest error, then we're not getting overfitting. So we do not need to do 3 partitions. We can just get by with 2 partitions. All right, so I'm going to go ahead and make a second partition then, so that we can just work with 2 partitions instead of 3. So we'll just do 0.6 and 0.4. All right, and let's rerun that with that validation partition. All right, so here in this result, it found that the best error was produced by K equals 15, and we can also see the confusion matrix down here.